Hello guys, today we are going to start our new chapter, chapter number 15, probability. Starting with the introduction, probability lies between 0 and 1 only, including 0 and 1. Probability of an event is equals to desired number of outcomes upon total number of outcomes. P of not E is equals to 1 minus P of E, which means the event which is not occurred probability is 1 minus the probability of event which has occurred. When there is a 0 probability, it is known as impossible event, and when it is 1, then it is known as sure or certain event. Starting the exercise 15.1, in that number 1 we have, it is blank given. In that number 1, probability of an event E plus probability of an event not E is equals to 1. We have studied in the introduction that probability of not E is equals to 1 minus probability of E. So we have to use that formula for this. In number 2, the probability of an event that cannot happen is 0 and it is known as impossible event, and the probability of an event that is certain to happen is 1 and it is known as sure event. The sum of probability of the elementary events of an experiment is 1, which means that probability of every small digits, by adding it together we get the 1 answer. The probability of an event is greater than or equal to 0 and less than or equal to 1. In question number 2, we are asked to check if the situations given are equally likely outcomes situation or not. In that number 1, a driver attempts to start a car. The car starts or does not start. It is not an equally likely outcome because here the description of car is not given. In second number, a player attempts to shoot a basketball. She or he shoots or misses the shot. It is not an equally likely outcome because the description about the ground or a player is not given properly here. Number 3, a trial is made to answer a true or false question. The answer is right or wrong. There are only two possibilities here, equally likely outcome. Number 4, a baby is born. It is a boy or a girl, two outcomes only. It is equally likely outcome. In question number 3, it is a theory based question. Why is tossing a coin considered to be a fair way of deciding which team should get the ball at the beginning of a football game? A fair coin when tossed, it gives a fair answer. It is head or tail. So the game starts with the fair means. In question number 4, which of the following cannot be the probability of an event? 4 options are given, 2 by 3, which is equals to 0 point something. In B, it is minus 1.5. The probability lies between 0 and 1 only. So negative answer cannot be. C, option C is 15%. Which means 0.15. It is between 0 and 1. And option D is 0.7. So correct answer will be option B minus 1.5. That is cannot be a probability of any event. Question number 5. If probability of event E is equals to 0.05, we have to find the probability of event not E. P of E is given 0.05 and we have to find the probability of not E. So the formula is probability of not E is equals to 1 minus probability of E, which is equals to 1 minus 0.05 is equals to 0.95. Question number 6. A bag contains only 11 flavored candies. Malini takes out one candy without looking into the bag. What is the probability that she takes out? 1. An orange flavored candy. The bag has only 11 flavored candy. So the probability of the orange flavor candy will be 0. So event E is a orange flavor candy and that probability of event is 0. In that number 2, we have to find a lemon flavored candy probability. There are only lemon flavored candy. So the probability will be only one outcome is possible there. So probability of event A, a lemon flavored candy, will be 1. In question number 7, it is given that in a group of 3 students, the probability of 2 students not having the same birthday is 0.992. What is the probability of 2 students having the same birthday? Here we have given P of E, probability of an event given, and we have to find P of not E. So the formula is 1 minus P of E, which is 1 minus 0.992. Which is equals to 0.008. Question number 8. A bag contains 3 red balls and 5 black balls. A ball is drawn at random from the bag. What is the probability that the ball drawn is red and not red? 2 questions are given. The ball drawn is red. So the probability of that A event is 3 by 8. As 3 red balls are there, the number of desired outcomes upon total outcomes. Total balls are 8. The probability that the ball is black means not red. So there is only one probability, that is red. Black. P of B is equals to 5 by 8. In question number 9, a box contains 5 red marbles, 8 white marbles and 4 green marbles. One marble is taken out of the box at random. What is the probability that the marble taken out will be red, white or not green? 3 questions are there. The event is the marble taken out at random is of red color. So probability of that A event is 5 upon total outcome 17. In question number B, second, we have taken event B, the marble taken out at random is of white color. So the probability of that event B is 8 upon 17. Number 3, the event C, the marble taken out at random is not green. Only 3 types of color are there in that box, red, white and green. If there is not green, there are 2 possibilities. There will be red or white. So we have to add the red and white probability and that will be the answer of not green. So 5 upon 17 plus 8 upon 17 is equals to 13 upon 17. In question number 10, it is given that a piggy bank contains 100 50 rupees coin, 50 rupees 1 coins, 20 rupees 2 coins and 10 rupees 5 coins. If it is equally likely that one of the coin will fall out when the bank is turned upside down, what is the probability that the coin will be a 50 paise coin and will not be a rupees 5 coin? So for the event A, the coin will be 50 paise coin. Probability of that event 50 rupees coin, desired outcome 100 upon total outcome 180, which is equals to 5 by 9. In second number, we have asked that will not be a rupees 5 coin. So we will find the first, it will be a rupees 5 coin. So probability of event C is equals to 10 upon 180 equals to 1 upon 18. Then it will be a not C, or we can say the event B will not be a rupees 5 coin. So probability of event B equals to 1 minus P of C is equals to 1 minus 1 upon 18 is equals to 17 upon 18. Question number 11, it is given that a gopi buys a fish from a workshop of his aquarium. The shopkeeper takes out 1 fish at random from a tank containing 5 male fish and 8 female fish. What is the probability that the fish taken out is a male fish? A tank containing 5 male and 8 female fish. Total 13 fish. We have to find probability of an event A. Fish taken out is a male fish. So P of A is equals to 5 upon 13. In question number 12, we are asked that probability that it will point. A game of chance consists of a spinning an arrow which comes to rest pointing at one of the numbers 1, 2, 3, 4, 5, 6, 7, 8. 8 numbers are there and the arrow will point any of this number. And these are equally likely outcomes. What is the probability that it will point at first at 8 number? Event A, the arrow will point at 8. So probability of that event is 8 is a 1 number and total outcomes are 8. So 1 upon 8. Of an event B, the arrow will point at odd numbers. From 1 to 8 there are 4 odds numbers. 1, 3, 5, 7. So 4 upon 8 which is equals to 1 by 2. Event C, a number greater than 2. A number greater than 2. It will be 3, 4, 5, 6, 7, 8. Total 6 numbers. So probability of an event C is equals to 6 by 8 which is equals to 3 by 4. Event D, a number less than 9. There are all the numbers less than 9. So it will be 1 probability. Question number 13, it is given that a die is thrown once. Find the probability of getting a prime number. Event A, a prime number. There are 3 prime numbers from 1 to 6. So probability of event A is 3 by 6 is equals to 1 by 2. In the second we are asked a number between 2 and 6. Event B, a number lying between 2 and 6. So between 2 and 6 there are 3, 4 and 5. 3 numbers. So probability of event B 3 by 6 is equals to 1 by 2. Event C, an odd number. There are total 3 odd numbers. 1, 3 and 5. So probability of an event C is 3 by 6 which is also equals to 1 by 2. Question number 14. One card is drawn from a well shuffled deck of 52 cards. Total there are 52 cards. Find the probability of getting a king of red color. Event A, a king of red color. So there are 2 kings of red color. So probability of event A is equals to 2 upon 52 is equals to 1 upon 26. Event B, a face card. In each type there are 3 face cards and there are 4 types. So there will be 12 face cards in 52 decks of cards. So probability of event B is equals to 12 upon 52 is equals to 3 upon 13. Event C is a red face card. There are 2 red types of red color and there are 3 face cards in each of them. So the total there will be 6 face card of red color. So 6 upon 52 is equals to 3 upon 26. Event D, the jack of hearts. There is only one jack of hearts. So it will be 1 upon 52. Event E, a spade. There are 13 spade cards. It is a type of a card. So 13 upon 50 is equals to 1 upon 4. Event F, the queen of diamonds. There is only one queen of diamonds. So the probability will be 1 upon 52. Now moving to question number 15. There are 5 cards. The 10, jack, queen, king and ace of diamonds are well shuffled with their face downwards. One card is then picked up at random. What is the probability that that card is queen? We have to find the probability that the random selected card is queen. So the probability of that event A is 1 upon 5 because there are total 5 cards and only one queen. Secondly, they have asked if the queen is drawn and put aside. Queen is drawn and then put side. So there will be total 4 cards. What is the probability that the second card picked up is an ace? We have to find the second card which is picked up is ace. So the event B, the card picked up is ace. The probability of that is 1 upon 4 because the queen is been selected and kept aside. So the total there is 4 cards. So 1 upon 4. In that they have asked the probability of a queen also. The card is queen. That is 0 because we have put it aside before only. In question number 16, 12 defective pens are accidentally mixed with 132 good ones. 12 defective pens are mixed with 132 good ones. There are total 144 pens. It is not possible to just look at the pen and tell whether or not it is defective. One pen is taken out at random from this lot. Determine the probability that the pen taken out is a good one. We have to find the probability that the pen is a good one. The event A. The probability of this event is total there is 144 pen and good one is 132. So 132 upon 144 is equals to 11 upon 22 is the probability of a good pen. Question number 17. In that number 1, a lot of 20 bulbs contain 4 defective ones. There are total 20 bulbs and then 4 are defective. One bulb is drawn at random from the lot. What is the probability that this bulb is defective? One bulb is drawn. We have to find the probability that the bulb is defective. The event is. So the probability of that event is 4 upon 20 which is equals to 1 upon 5. In that number 2, suppose the bulb drawn in number 1 is not defective and is not replaced. Means the bulb is here is taken up is not defective and is not replaced. Now one bulb is drawn at random from the rest. What is the probability that the bulb is not defective? 4 bulbs are defective. Before also and after random choosing, the bulb was not defective. So 4 defective bulbs will be there. But that one which was not defective, that was not replaced. So total there will be 19 bulbs. Non-defective bulb is equals to 19 minus 4, 15. Even if the bulb is not defective, you have to find the probability of the bulb that is not defective. So the probability of that event is 15 upon 19. Question number 18. A box contains 90 discs which are numbered from 1 to 90. If one disc is drawn at random from the box, find the probability that it bears a 2-digit number, a perfect square number, a number divisible by 5. There are total 90 discs and 1 to 90 is written on each disc. A 2-digit number, 1 to 9 are 1-digit number. After that starts the 2-digit number. So 90 minus 9 which is 81. So probability of that event A is equals to 81 upon 90 equals to 9 by 10. A perfect square number. There are total 9 perfect square from 1 to 90. So 9 upon 90 is equals to 1 by 10. A number divisible by 5. There are total 18 numbers which are divisible by 5 in between 1 to 90. So 18 upon 90 is equals to 1 upon 5. Question number 19. A child has a dice whose 6 faces shows the letter A, B, C, D, E and again A. A dice is thrown once. What is the probability of getting A and D? Event E getting the A side face. P of E, there are 2 A. So 2 by 6 is equals to 1 by 3. And getting D is equals to 1 by 6. Question number 20. Suppose you drop a die at random on the rectangular region shown in the figure. What is the probability that it will land inside the circle with diameter 1 meter? So the radius here is 0.5 meter because the diameter is 1 meter. You have to find the probability that the die will land in the circle. Area of the rectangle is L into T. This 3 into 2 equals to 6 meter. And area of the circle is pi r square. Pi into 0.25 whole square, which is equals to pi by 4 meter. We have to find the die line on the circle, event A. So the probability of this event A is area of a circle upon area of a rectangle. So pi by 4 upon 6, which is equals to pi upon 24. In question number 21, a lot consists of 144 pens in which 20 are defectives and the others are good, means 124 are good ones. Noori will buy a pen if it is good, but will not buy if it is defective. The shopkeeper draws one pen at random and gives it to her. What is the probability that she will buy and she will not buy? She will buy if the pen is good one. So the probability of A is 124 upon 144, which is equals to 31 upon 36. She will not buy if the pen is defective. The probability of she will not buy will be 20 upon 144, which is equals to 5 upon 36. Question number 22. Refer to example 13. Complete the following table. Here we have the outcomes of the two dice thrown. 1, 1, 2, 1, 3, 1 and so on. We have to find the sum of the dice. 2 is given. We have to find 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So first we will write all the possible outcomes here. Event A, the sum on die is 3. There are two outcomes for which the sum is 3. So 2 upon 36. Sum on die is 4. There are 3 outcomes with 4 sum outcomes. So 3 upon 36. Sum on die is 5. There are 4 outcomes in which the sum of both the dice is 5. So 4 upon 5 upon 36. Only one, sir. Only one. Question number 22. Refer to example 13. Complete the following table. Here you have write the outcomes when the two dice are thrown. There are total 36 outcomes, 1, 1, 2, 1, 3, 1 and so on. We have to find the sum on the die 3, 4, 5, 6 to 12. Here sum on die is 3. There are 2 outcomes when the sum of both the dice are 3. So 2 upon 36. Sum on die is 4. There are 3 outcomes when the sum on both the dice are 4. So 3 upon 36. Sum on die is 5. There are 4 outcomes when the sum of both the dice are 5. So 4 upon 36. Sum on die is 6. There are total 5 outcomes when the sum on die is 6. So 5 upon 36. Sum on die is 7. There are total 6 outcomes when the sum of both the dice is 7. So 6 upon 36. Sum on die is 8. There are total 5 outcomes when both the dice sum is 8. So 5 upon 36. Sum on die is 9. There are total 4 outcomes when the sum of both the dice becomes 9. So 4 upon 36 is the probability. Sum on die is 10. There are total 3 outcomes when the sum of both the dice becomes 10. So 3 upon 36. Sum on die is 11. There are 2 outcomes where the sum of die is 11. So 2 upon 36. And sum of die is 12. There are only 1 outcome when there is the sum of die is 12. So 1 upon 36. In that second number, a student argues that there are 11 possible outcomes. 2, 4, 3, 5, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Therefore, each of them has a probability 1 upon 11. Do you agree with this argument? Justify your answer. No, because the 11 sum are not equally likely outcome. A game consists of tossing 1 rupee coin 3 times and noting its outcome each time. Hanif wins if all the tosses give the same result. That means 3 heads or 3 tails, and loses otherwise. Calculate the probability that Hanif will lose the game. Tossing 1 rupee coin 3 times, there are 8 possible outcomes. Similarly, alternatively, and all heads and tails. A Hanif will lose the game if same result doesn't come out. So there are 6 outcomes which doesn't have the same result. So 6 upon 8 is equals to 3 by 4. The losing probability of Hanif is 3 by 4. Question number 24. A die is thrown twice. What is the probability that 5 will not come up either time? Or 5 will not come up either time. 5 is not there in the 1 to 36 outcomes which we have done before. In question number 21 outcomes we have written the 2 dice. So in 25 outcomes there is no 5. So 25 upon 36. And the second is 5 will come up at least once. Means it is opposite of this. So not A is equals to 1 minus P of A equals to 1 minus 25 upon 36 equals to 11 upon 36. Question number 25. Which of the following arguments are correct and which are not? Give reasons for your answer. If 2 coins are tossed simultaneously, there are 3 possible outcomes. 2 heads, 2 tails, or 1 of each. Therefore, for each of these outcomes, the probability is 1 by 3. False, because there are 4 possible outcomes. Head, HH, PT, XT and TH. Head. Alternatively, these 2 are different outcomes. So, the statement is false. Second number, if a die is thrown, there are 2 possible outcomes, an odd number or an even number. Therefore, the probability of getting an odd number is 1 by 2. So this statement is true because there are equally likely outcomes here. Here we have completed our exercise 15.1 and chapter number 15 also. We will meet with the new chapter. Till then, subscribe the channel and like the video.